This is what is waiting for you. Right. So we were discussing, before discussing second law, we discussed something called momentum. Is this clear? Does anyone remember what is momentum? Momentum is a vector quantity represented by P, and the magnitude of P is given as mass into velocity. And since velocity is a vector, momentum is also a vector quantity, right? Momentum is also a vector quantity. And in SI unit, if we try to find the unit of momentum, it will be mass is in kg, velocity is in meter second minus 1. So the unit of momentum is kg meter second minus 1. Nothing great. This much to samajh mein aaya hoga. Right. Now in the last class I also tried to make you understand what happens to change in momentum. Let's understand another topic now. Change in momentum. Let's try to understand this concept. Change in momentum. So change in momentum I can write as delta P. Delta means any change. So change in momentum should be equal to final momentum minus initial momentum. Final momentum minus initial momentum. Clear? ठीक है. तो अगर हम इस चेंज इन मोमेंटम को अच्छी तरह से देखें, सो कैन वी राइट इट एज m into v is final velocity, minus m into u. Final momentum should be mv, initial momentum is mu, u is initial velocity. Now थोड़ा इसमें थोड़ा सा एक चैप्टर में एक चीज है जो हम आगे देखेंगे. So I can take m common, I can write it as mv minus u. This is change in momentum. Final momentum minus initial momentum. ठीक है? Now this is a very baby approach to studying change in momentum. This you study in grade 9, but in grade 11 we won't study like this. This you are studying about those objects. This typically applies to what type of an object? A body of mass m with a velocity v, okay, with a velocity let's say u at a time t1. After some time this body is of mass m acquires a velocity final v at a time t2. So our change in momentum, we say the body of mass m with an initial velocity, this is the body of mass m with final velocity. So if you multiply these two, you get the initial momentum. If you multiply these two, you get the final momentum. इतना समझ में आया कि नहीं? लेकिन यहाँ पे कैच है, आप यहाँ पे ऐसा एक केस पढ़ रहे हैं in which you are taking mass constant. Body may lose mass also. So how is this possible? Rocket, as you are going up, you are offloading your fuel. So the approach that we will be doing in grade 9, in our grade 9, whenever we study about change in momentum, mass of the body is supposed to be constant. We take mass constant. We don't study about those cases where the body is also losing mass. Are you understanding what is a body losing mass? Suppose you have a space shuttle which has disintegrated and is coming down. Every time it's losing some part of its body. So the mass is also changing with every time. We are not considering those. We are considering where the mass is constant. समझ में आया? Now, let's say that at t2 time, this is particularly the final momentum is pf, and at t1 time, the initial momentum was m2. So change in momentum. And I write here, what is the change in time? The change in time can be written as t2 minus t1. ये समझ में आया? And t2 minus t1 is nothing but, I can write this as delta t. So if I say change in momentum, okay, over change in time, change of time, or we don't write change of time, we rather write time elapsed. The time that has elapsed for this change in momentum, I can write it as delta t and delta p over delta t. ये समझ में आया? ये तो सिंपल है, ठीक है ना? ये जो क्वांटिटी है ना, इस क्वांटिटी को हम बोलते हैं रेट ऑफ चेंज ऑफ मोमेंटम. रेट ऑफ चेंज ऑफ मोमेंटम. बेटा, whenever a change is compared over change in time, it is called rate of change. If you are having little bit of confusion, just try to think, what is velocity? Rate of change of displacement. Velocity is rate of change of displacement. What is acceleration? Rate of change of velocity. So this is rate of change of momentum. Have you understood? Rate of change of momentum. तो चीज समझ में आया? अब इसको सीधा भाषा में देखें तो व्हाट इज रेट ऑफ चेंज ऑफ मोमेंटम? वी आर ट्राइंग टू सी हाउ इज द मोमेंटम चेंजिंग विथ रेस्पेक्ट टू टाइम. समझ में आ रहा है? एक सेकंड में मोमेंटम चेंज हुआ सो एंड सो, इन नेक्स्ट सेकंड मोमेंटम चेंज सो एंड सो, इन नेक्स्ट सेकंड मोमेंटम चेंज सो एंड सो. इट्स समथिंग लाइक यू हैव अ बैंक बैलेंस, right after the day you get your salary, our bank balance is पूरा भरा हुआ है. Then as you start making expenses, your bank balance is decreasing. So generally in a salaried person, what would you see? On 7th he becomes very poor because all home loan, car loan सब debit हो जाएगा. 7th is the date in India when all your loans get debited. So if you see the rate of change of decrease in bank balance, for the first 7 days there will be a drunk decrease. After that there is no more loans and all. It is the man himself, his own expense. So the rate of change of decrease in bank balance for the next 7 days will be less. Are you understanding? Rate of change. अब इस चीज को, अगर आपको ये चीज क्लियर हो गया है, then we are now ready to define what is known as Newton's second law. Right? Shall I go? Now let's go to Newton's second law. I'm not erasing this. So what all did we study? We studied about a quantity called momentum. Momentum is said to be the mass product of mass and velocity. It's a vector quantity. When you do mass and velocity, you are only getting the magnitude. If you want to know the direction of momentum, then the direction of momentum will be along the direction of velocity because this is a vector quantity. All we are interested here is change in momentum, which is final momentum minus initial momentum. Final momentum is mass into final velocity. Initial momentum is mass into initial velocity. So you take m common, it becomes v minus u. This is your change in momentum. And this change in momentum has happened over a time. Understood? So let's take one example and again try to see what is the change in momentum. Now, let's say a cricket player is standing out here, right? And the ball is right now here, and since we are in grade 9, so we'll only consider about scenarios where the mass is constant. So right now the ball has a mass m and it has an initial velocity u, and the ball is traveling towards this fielder, right? And when the fielder catches the ball, and let's say this time is t1 and this time is t2, so the fielder has taken the ball and its final velocity is now v is equal to 0. एक समझ में आया? Right? So what was his initial momentum? If we see what is the initial momentum, it was mu. And what is the final momentum? Sir, the final momentum was 0. And this has happened over a time interval of t2 minus t1. So here if you want to find out what is the rate of change, what is the rate of change of momentum? So it will become pf minus pi divided by t2 minus t1. So pf is our 0, this is mu divided by say delta t, t2 minus t1 is delta t, so we say minus mu by delta t. Rate of change is negative, obviously. Suppose you say in my business the growth rate is positive, that means आज मैं जितना कमा रहा हूं कल और ज्यादा कमाऊंगा. If my business's growth rate is negative, means it doesn't mean you are going to make loss. This year we earned a profit of say 2 lakhs. It is lesser than something, but on some day we will make loss. If there is a negative growth rate in my business, today I made a profit of say 10 lakh, tomorrow I'll make a profit of less than 10 lakh, less than, and at one day I will make no profit, and that very next year I will start making 0. यहाँ भी तो negative क्यों है? क्योंकि momentum तो घटता जा रहा है ना, देखो momentum is reducing. You think it like acceleration negative, dv by dt, if is this negative, that means what? The velocity decreases. So the momentum is decreasing. यहाँ पे 0 हो रहा है. Change in momentum समझ में आया? Now, can I rub this side?
Yes, sir.
Okay. So another thing that we need to see here is that now ultimately what is the change in momentum when the fielder catches the ball? The change in momentum is always going to be minus mu. We cannot change the momentum of the ball. Ball is coming with a velocity u and has a mass m. The moment I catch it, velocity becomes 0, mass remains m. What I can also do is that I can increase the time span of catching it. और लेट से पकड़ो, यहाँ हाथ लगाने की जगह मैं बॉल को हाथ पीछे लेके समवेयर यहाँ पे हाथ लगाता हूँ और बॉल को यहाँ पकड़ता हूँ. So don't you think the denominator has gone up? If the denominator goes up, this whole quantity comes down. Rate of change of momentum has come down. Have you understood? अच्छा. अब देखते हैं what is Newton's second law. Newton's second law is all about mathematically defining the force which was defined by first law. So first law we had got something called F net. Newton says this F net is directly proportional to the rate of change of momentum. Rate of change of momentum. That means I can write that F is directly proportional to delta P over delta T. Have you understood? Right? Can I write this as this is directly proportional to mv minus mu divided by delta T? लिख सकते हैं? Okay. Or this is directly proportional m common v minus u by delta T. Or it is directly proportional to m delta v by delta T. V minus u is nothing but change in velocity. What is this quantity? You know this quantity. Acceleration. So force is directly proportional to mass into acceleration. अब आना शुरू हो गया. हम बोलते थे ना whenever there is F net there should be an A. A का जन्म हो गया. ये समझ में आया? Delta V by delta T is A. Now when you were in grade 8 and you had a relation like this, if you want to convert it to equal, you have to put one constant of proportionality and then write MA. Agreed? Some constant. In SI unit, this value of K is equal to 1. So we get the expression force is the product of mass into acceleration. Mass into acceleration, ये आपका force होता है. समझ में आया? K in SI unit is taken as 1. फिर से जरा समझो. Newton's second law says, definition बाद में देखेंगे, पहले इसको. The force. Sir, so in that sir, you wrote F is equal to K. So sir, what is K is constant of proportionality. This is grade 8 direct and inverse variation chapter. I'm not teaching anything new. Grade 8 में आपने पढ़ा था ना. If something varies directly with, अरे यार, mathematics इतना कमजोर होने से कैसे होगा? X and Y, if they vary directly, this is x1, y1. So what did you get? X is directly proportional to Y. That means X is equal to some constant K into Y. So X over Y is always constant K. This will be this ratio, this ratio, this ratio. They used to be all equal. याद आ रहा है कि नहीं? हमने कितने problems किए थे? Yes, sir. From R.D. Sharma. Yes, sir. And if you say inverse variation means X is inversely proportional to Y. So in that case, X will be equal to K into 1 by Y. So in inverse variation, product is always constant. In direct variation, ratio is always constant. So this K into M into L. Let's understand once again. Newton says the net force that we have talked about in the first law is directly proportional to the rate of change of momentum. That means force is directly proportional to rate of change of momentum. I have written it mathematically. Change in momentum by time taken. That means force is directly proportional to m v mu by this. M taken common, v minus u by t. You can also write delta t as t. Then v minus u by t is a. Right? But in this whole expression, one thing that you have silently taken to your liking is you took the mass constant. Whereas when you do problems in grade 11, you are not allowed to keep the mass constant. How do you know the mass is constant? Mass lose भी हो सकता है ना? A child who is running and puking parallelly, losing mass, और साथ में डायरिया भी हो गया है. नहीं, उसका अलग रहेगा, वो भी दिखाएंगे. ये इतना समझ में आया? अच्छा, अगर इतना समझ में आया तो कुछ और देखते हैं. Now let us see what should be the unit of force. Okay, so what should be the unit of force? Force is given as in SI units. Whenever we are in SI, we say force is MA. इसको हम लोग ऐसे पढ़ते हैं, father equal to माँ, father equal to mother, माँ, MA. ठीक है? तो M का यूनिट क्या होता है? kg. Acceleration is meter per second square. So the unit of force should be kg meter per second square, और इस यूनिट का नाम है न्यूटन, denoted by N. डिनोटेड बाय n। ठीक है, तो कुछ ऐसे लिखें, 1 न्यूटन शुड बी इक्वल टू 1 kg into 1 meter per second square. Are we in a position to define 1 Newton now, looking at this expression? So we say 1 Newton is the force which, when acts on a body of 1 kg, produces an acceleration of 1 meter per second square. अगर आपने एक 1 kg के बॉडी में 1 न्यूटन फोर्स लगा दिया तो उसका एक्सेलरेशन कितना हो जाएगा? 1 meter per second square. What I mean to say is that, let's say we have a 1 kg ball. We have a 1 kg ball. Time now is 08:00:00. सुबह के 8 बजे हैं, ठीक है? And then you put a 1 Newton force on it. There is no friction, nothing. This is Newtonian environment. In that case, when the time is 08:00:01, the velocity here is how much? 0. The velocity will be 1 meter per second. Then at 08:00:02, the velocity will be how much? 2 meter per second. Because the acceleration is 1 meter per second square. What is 1 meter per second square? 1 meter per second per second. Speed कैसे बढ़ रहा है? हर सेकंड में 1 मीटर पर सेकंड बढ़ जाएगा. इन द फर्स्ट सेकंड 0 पे 0 था, फर्स्ट सेकंड में 1 मीटर, नेक्स्ट सेकंड में कितना हो गया? 2 मीटर्स, थर्ड सेकंड में 3 मीटर्स. So in how the noise comes, ऐसे बढ़ रहा है speed. Why was the speed? Now my question to you: why was the speed not like देखता हूं आपका कितना मन है पढ़ाई में. Why is the speed not like this? Look at the data. At 08:00:03, what would be the speed equal to? 3 meters per second.
Because the force is constantly being applied, so like the acceleration is there.
The velocity is continuously changing.
कितना सोचते हो? फर्स्ट लॉ क्या कहता है? If F net is acting on a body, body cannot be in uniform motion. F net is acting na. So how can you expect? यूनिफॉर्म मोशन होने के लिए क्या होना चाहिए? F net 0 होना चाहिए. And I am asking, means uniform motion. Newton said that only, na? Galileo said that. You remain in uniform motion as long as there is no net force. Bhai sahab, you have given a net force. So your uniform motion is straight away disturbed. And you will have now an acceleration. Yes, it is accelerating. Force will always, therefore I always say like this. Why I am saying, here about net force, acceleration is born. Acceleration is born. समझ में आया? थोड़ा और देखते हैं. इतना हो गया तो आज बहुत कुछ समझ में आ गया आपको. Now, right. So we have come to this expression now. Force is equal to mass times acceleration, and in SI unit, force is expressed in newtons. Okay, Newton, and denoted by N. And what is 1 Newton force? We say 1 Newton is the force which when acting on a body of 1 kg, which when acts on a body of 1 kg, produces an acceleration of 1 meter per second square. Clear? This is SI unit. There is another unit also which is known as CGS. As I told you, CGS stands for centimeter, gram and second. CGS unit में the mass will become grams and 1 meter per second square will become 1 centimeter per second square. Agreed? Because this is CGS. In that case, we call the unit of force as dyne. Dyne mat likhna. Dyne matlab which? Dyne. Dyne. So what is 1 dyne? 1 dyne is a very chota force. 1 dyne is the force which when acts on a body of 1 gram produces an acceleration of 1 centimeter per second square. Means the problem that I gave you, 801, 802, here it is 1 centimeter per second square. ठीक है, अब इसका कन्वर्शन देखते हैं. हाउ टू कन्वर्ट? लेट्स से 1 न्यूटन, वी से 1 न्यूटन वर्सेस 1 डाइन. लेट्स डू दिस कन्वर्शन. ये सब करो फिजिक्स में, तब मजा आएगा. 1 न्यूटन इज इक्वल टू 1 kg into 1 meter per second square. 1 kg can be written as 1000 grams and 1 meter can be written as 1000 centimeter per second square. This can be written as 10 to the power 5 gram centimeter per second square, and 10 to the power 5 into 1. And what is 1 gram? This is nothing but 1 dyne, है ना? So 1 Newton equals to 10 to the power 5 dynes. This is sometimes asked in your fill in the blanks. 1 Newton is 10 to the power 5 dynes. करके देखो आप, don't copy from the board blindly. You do on your own and you try to see. Why don't you write, Siddharth? नहीं, looking है. If you are coming into observation means there is something garbar.
Only 7 fundamental units. Like,
7 fundamental units, yeah.
I think dyne was also.
No. 4 dyne cannot be there. 1 minute. The fundamental units are fundamental. Force is a derived unit. Force में देखो mass भी है, time भी है, length भी है. Fundamental unit में इतना कुछ नहीं होगा. Fundamental unit is a fundamental. Fundamental units give birth to other units.
CGS unit dyne is the SI.
In CGS unit, force is measured in dyne, and in SI unit, if you go by fundamental units, then we have kg for mass. हमेशा MLT याद रखो, meters for length and T is time, second हो गया. उसके बाद चैप्टर वाइज याद रखो, हीट से आया टेम्परेचर केल्विन, इलेक्ट्रिसिटी से आया एम्पियर, ठीक. और कौन रह गया है? अमाउंट ऑफ सब्सटेंस मोल. लाइट से आया कैंडेला. 7 हो गया. These are all known as derived units. ये जो आप पढ़ रहे हो इनको derived units बोलते हैं. So we just saw the derivation of how 1 Newton can be said as 10 to the power 5 dynes. Again understand, what is 1 Newton? 1 Newton is the force which when acts on a body of 1 kg produces an acceleration of 1 meter per second square, and the acceleration will remain. Sir, when will the acceleration become zero? When that force has been nullified. How? But generally sir, if you apply 1 Newton force to a ball, the ball doesn't accelerate. वो तो जाकर रुक जाता है क्योंकि फ्रिक्शन आ गया ऑपोजिट में, ग्रेविटी आ गया ऑपोजिट में. They have all killed that force. Body comes to rest. Follows Newton's law. Newton's laws are not proved. Nobody has proved. But nothing happens in this universe that contradicts what the laws are. ठीक है, कुछ और चीज देखते हैं. तो one small recap. अभी तक आपने क्या क्या पढ़ा? Till now you have studied about momentum. Today momentum you have studied. Then you studied about change in momentum, and ask yourself whether you have understood these topics or not. Otherwise आप problem नहीं कर पाएंगे आगे. Change in momentum. Then you understood what is rate of change of momentum. If you still think that between 2 and 3 you are not understanding, then think that I am a maid. This is my salary. Rate of increase of salary. हर साल बढ़ाते हो मेरा तनख्वाह, हर महीने बढ़ाते हो. रेट मीन्स विथ रेस्पेक्ट टू टाइम. ठीक है, ये सीख लिया आपने. फोर्थ आपने देखा कि फोर्स इज डायरेक्टली प्रोपोर्शनल टू द, दिस इज न्यूटन सेकेंड लॉ, इज फोर्स इज डायरेक्टली प्रोपोर्शनल टू डेल्टा पी बाई डेल्टा टी. एंड फ्रॉम हियर यू गेट द इक्वेशन force is equal to k into m into a. K's value is 1 when it is in SI units, and you are solving everything in SI. The force is mass into acceleration. If you still think that you need derivation help, mv minus mu divided by delta t, which is m common v minus u by delta t. I think by now you know this is m into a. ठीक है. Fifth thing that you learned is that 1 Newton is 1 kg multiplied by 1 meter per second square, and you also learned that 1 dyne, not Diane, Diane मतलब चुड़ैल, ये dyne है भाई साहब. 1 gram into 1 centimeter per second square. Clear sir? So far, check yourself on all these 6 balai. If any bala is not understood by you, stop me right then and there. It is very, very surprising, specifically Anya, Yashvi. So much of classes of physics happen, you all don't have any query. It is simply not possible to understand. Either you are understanding everything or not understanding. And if you are understanding everything, then you all are specimen to be preserved. ऐसा हो ही नहीं सकता है कि फिजिक्स में सब समझ में आता है. मैं आज भी पढ़ता हूँ तो announcing I am great. I everyday learn. I am teaching you, I am learning something. ठीक है? Just check whether you have understood these things or not. Yes, because unless and until you have interaction, हो नहीं सकता है. And interaction always, if you do interaction, one good thing happens is your interpersonal skills also develop. कल आप कंपनी में नौकरी के लिए जा. Why are you studying? First of all, tell me. Why are you studying? To earn a livelihood. Unless and until you inherit the family of an industrialist or you have something, you will be going to do job somewhere, either in some private or company or something. There, don't you think conversation will be liked? आप चुप रहोगे तो हमको थोड़ी पता आपके अंदर कितना ज्ञान है. Because in the company there are various roles. We find that yes, this fellow can work hard and slog, but he's a snob. ले लो इसको, फैक्ट्री में बिठा के रखें, काम करवाएंगे इससे बढ़ बढ़ के. This fellow is good talkative, गोलीबाज है, and can manage. रखो इसको client handling में. There's a lovely write-up once I got. The teacher used to turn me every time out of the class and I was outspoken. I am today in the Indian Army. It's like that. And I am someone who always studied. I never played. What I am doing? I'm married and I am just bringing up kids at home. और कुछ नहीं हुआ लाइफ में, खाली पढ़ाई अच्छा हुआ. ऐसा नहीं. इसलिए सवाल पूछिए. सवाल पूछने से आपके स्किल्स बढ़ते हैं बातचीत करने का भी. और मेरे हिसाब से, if you ask me in today's world, do children need this gyan? This gyan is available everywhere, much better than what I am teaching you. What is not available is things, skills that I have forgotten over time. Very bad definition, huh? Be ready to listen to it. What are soft skills? Manners, etiquette and skills that I have forgotten over time, or my mom didn't teach me. Second part is very harsh. डायरेक्ट माँ पे अटैक हो गया है और my mom didn't teach me. इसीलिए तो आप ऐसे बने हो. और नहीं तो क्या? बचपन में हमें सिखाया जाता है ना, अच्छा टॉफी ली अंकल से, बोलो थैंक यू बोलो. आपको नहीं सिखाया, इसलिए आप नहीं बोलते हो. Soft skills definition that things that you forgot over time or your mom didn't teach you. अब आप माँ पे तो ये इल्जाम नहीं लोगे. So better you say no sir, I learned it, I forgot over time. तो बात करो. Hard skills. Do you get a Java coding guy? Yes sir, we can get. Can you get a Java coding guy who has a broad smile and can interact with everyone, tell about the issue? Difficult to find that resource. Difficult to find that resource. This guy doesn't know Java, we can teach him. But if this guy doesn't mix, नहीं, बहुत मुश्किल है. That resource we won't get. और आपका your valuation will increase like anything in the company once you are like a honeybee who can attract people and you can manage things. Bolo sir.
Like in a Newtonian environment.
Yes.
Like if an object is moving, there must be like there's some force applied on it, right?
There must be force applied on it. Yes.
So the net force, is it zero or is there some net force?
If there is a net force acting on the body at that time, the body cannot be in uniform motion. That's it. It's
Net force will be total force.
total of all forces. Of all forces right now acting. Right now, right now in Newtonian environment, if I draw your free body diagram, I compute all the forces in x direction, all in y, and finally if I say no, there is one net force that is acting on you, then you are not in uniform motion.
Net force is the combined forces.
Combined forces that you don't know now because you don't know vector resolutions. We will see that when we go to next to next chapter. Work, energy, power. We'll see combination of forces. है ना? जैसे आपकी मम्मी आपको इस हाथ से पुल कर रहा है, आपका डैडी इस हाथ से पुल कर रहा है, तो आपके बीच में से फट जाओगे, आप सीधा चलोगे. How does a paratrooper pulls from this side, pulls from this side? Where is the paratrooper descending? That is the net force. This one. अब घर जाके ये डेनिम खोलना है तो लोग कैसे खोलते हैं? बटन खोल के जिप और ऐसे तो नहीं खोलते हैं, पचाक खींच देते हैं. Don't we? Many people open zips like this. So how does the zip run? Vertically downwards. How are you pulling it? Like this. कपड़ा फाड़ना है तो कैसे फाड़ते हो आप? ऐसे. कपड़ा किस तरफ फट रहा है? ऐसे. That is net force. Of all force that are acting on you. ठीक है? ये समझ में आया? Now let's look at Newton's second law once again. So Newton's second law says that F is equal to delta P over delta T. We need to understand this. change in momentum over time. Change in momentum over time. And I am now saying, now if you want to increase this force, अभी mathematics जैसा समझो, if you want to increase this force, one way would be that, sir, if the time is same, then increase the change in momentum. If the time is same, then increase the change in momentum. Please understand. They have said that the time that is allowed to you is from 5th second to 8th second. So how much time they are allowing you? 3 seconds. And say this is frozen. 3 seconds में हमने एक force create किया which is say F newtons. They tell that in 3 seconds you create a force which is more than F. What do? This is frozen.
Newton plus X.
This is frozen. Think like a mathematician. This is frozen. You want to jack this up. So you have to jack the numerator.
Yeah.
You have to increase the momentum. How can you increase the momentum in grade 9? Mass you cannot play with. So, not momentum, change in momentum. Change in momentum. Mass you cannot play with. So, if this quantity has to be increased, you even forget about this. You have to increase the difference of V and U. समझ में नहीं आया? चलो. I want to increase delta P. So, what do I have to increase? M into V minus U. This whole quantity has to be increased. But this is constant. So, इसको भी भूल जाओ. You cannot make me double fat, na? Delta V. How can you increase delta V? Either you increase this one and reduce this one, because initially you have no control, or you just, no, you have to increase the difference. If you want to increase the difference, then how do you increase it? It can be a negative difference or a positive difference. If you want to increase the difference, either V goes up and U is less, either V goes up and U is less, बुलेट फाइनल वेलोसिटी पिस्तौल से निकलते वक्त ठाक उसके बाद शाट करके जाता है. बुलेट के पास ज्यादा फोर्स होता है? हाँ सर होता है, हमको चीर फाड़ के चला जाता है, होता है ना. और एल्स फाइनल वेलोसिटी को कम करो और इनिशियल वेलोसिटी को जैकअप करो. थप्पड़. फाइनल वेलोसिटी को जीरो कर दो, इनिशियल वेलोसिटी को एकदम दो जोर से पटास करके हो जाएगा. इट विल बी, कुछ नहीं होता है, आप समझो वो ज्यादा इंपॉर्टेंट है. अ स्लैप इज एन एग्जांपल ऑफ दैट. आल्सो फोर्स इज मोर. यू इंक्रीज द इनिशियल वेलोसिटी, फाइनल वेलोसिटी विल बी जीरो, बिकॉज बाय दैट टाइम माय हैंड विल बी ऑन योर चिक, है ना. ऐसा करने से आपको याद रहेगा. इन बोथ केसेस द चेंज इन मोमेंटम इज मोर. आर यू अंडरस्टैंडिंग? The change in momentum is more. Now let us see. I want to reduce the speed. I want to reduce the force. Force equal to delta P over delta T. I want to reduce it. So if I want to reduce it, one way is what? Reduce the difference. Reduce the difference. But this time we'll play on time. If you want to play on time, then you have to increase the time. Bas. Take the catch after some time. Allow your hands to come along with the ball. The pain is less. The pain is less. And if you just keep your hand out here, ठाक से आके लगेगा.
Sir, I have a doubt.
Yeah.
Do we do that to like match the?
Not match the momentum. You're doing that to reduce the impact of force on your hand. So if the force has to come down, this whole quantity has to come down. But this whole quantity, see, ultimately the ball has been hit with some initial velocity. Is it in your control? No. When you take the catch, the final velocity will be zero. Is it in your control? No. So you cannot play on numerator. So you start playing on the denominator. Time is in your control. भाई साहब, 1 सेकंड में कैच लेने से अच्छा है 3 सेकंड में कैच लो. Force कम है. Now you yourself think. Now the same example. There is a guy who is jumping and he is jumping from this height on concrete. So concrete में jump किया and the time taken is say t. Time taken is t. So when he jumps over here, this ground is going to give a reaction force to his knees, due to which he will get some hurt. Agreed? Now if you want to reduce this force, you have to reduce that quantity. His final velocity will be zero. We can't help it. His initial velocity is with what he kudo fight. We can't help it. So what do we do? Put one trampoline. Trampoline will make sure that he doesn't stop here, he stops here. T plus T dash. Time बढ़ गया. अब चोट कम लगेगा. If trampoline doesn't let you go, if trampoline that will see again third law, trampoline doesn't get you लोगों चोट लगेगा आपको. चोट तो लगेगा ही. That's the reason we when we make you jump over Dunlops and all, you don't get hurt. And again, if you want that, no sir, the other day when I said that karate guy, the person who is into martial art, he has to break what a martial arts guy has to break so many tiles together, right? So here when he strikes, there will be some velocity v, sorry, some velocity u, initial velocity. And by the time his hand comes here, there will be a final velocity which will be 0, has to be, right? This he will strike, this he will do. So what he has to do? Force बढ़ाना है, तभी तो ये सब टूटेगा. The force that is acting on all the tiles has to be more. Then only they will break. So if the force has to be more, then he has to overall increase this quantity. So he can definitely increase the initial velocity by starting with a great thing. But what he should do is do it very fast. Time को कम कर दो. Time को कम कर देगा तो force बढ़ जाएगा और थांग से सब टूटेगा. Yes.
5 newtons. Right?
5 newtons.
So, in the first instance, catches it. Now, you again throw the ball at 5 newtons.
You
same mass.
you
and
are.
then he catches it like this.
हाँ, तो उसमें time भी कम लगेगा. It is the force.
The force decrease.
The force will decrease automatically.
You have already applied the force of 5 newtons.
5 Newton force. Force is directly proportional to the rate of change. आप 5 Newton से ball को throw किए हो. The ball is so what is force equal to mass into acceleration. आपका फोर्स 5 न्यूटन से मारे हो, मेरे तक आते आते एक्सेलरेशन क्या रहता है? घट नहीं जाएगा मेरे तक आते आते, डिस्टेंस भी तो कवर कर रहा है ना. एक्सेलरेशन कमेगा घटेगा भी तो. It is to be seen what is the force on my hand, not what is the force on your hand. ठीक है? So what does second law tell you? And second law से ही सारे problems आते हैं. Second law tells us that the force acting on a body is directly proportional to the product of mass and acceleration. In grade 9 we learn as that the second law tells you that the force acting on a body is directly proportional to the rate of change of momentum, or you can say the force acting on a body is directly proportional to the product of mass and acceleration. So F is directly proportional to ma, F equal to ma. Now let's see some CBSE type of problems. अब ये सब हमने सीख लिया. Now we are going to connect our first chapter and our second chapter, and then let's try and solve some problems. Okay. Right. Now, typical CBSE problems. A body has a mass of 5 kg, acceleration 2 meter per second square. Calculate the force acting on it. And ये problem आएगा आपको स्कूल में, ऐसे भी आता है. 10 Newton. 10 Newton. Or they'll say the force is 10 Newton. The mass is 5 kg, calculate the acceleration that the body will encounter. These all are force acting on the body. Always remember, as long as you are in Newton's second law, you are only thinking about force acting on a body. First law tells you about F net, second law tells you, ये F net के बारे में ही बात हो रहा है. First law only tells you about F net, first law tells you about F net, second law tells that F net is equal to ma. That's the part. Third law will be the first law which will give this body a right to exert a force. ये कोई वो है क्या, bean bag है क्या? Every time you are only acting force on it, you should give it also some right. So let's do some problems from second law, ठीक है? Which will involve our Suvat equations also. देखते हैं whether we are able to do or not. Here a question है, what force would be needed to produce an acceleration of 4 meter per second square on a mass of 6 kg? 24 Newton. Okay. Calculate the force required to impart a car a velocity of ये सब टाइप, ये सब क्वेश्चंस करते हैं. ये भी वैसे ही है, बच्चा सवाल.
So they can also like tell person and
So, acha. So, yeah. So let's say this question is something like this. See, let me draw it so it becomes clear for you. Again, so we have a car. It says calculate the force required to impart to a car. I want this car. I want this car to pick up a velocity of 30 meter per second in a time of within 10 seconds. You know, whenever you go for car ads, you'll see they'll always write about bike ads will always have that 0 to 180 in 6 seconds. Means the engine is very, very powerful. So now you need to calculate what is the force required. So how much force, rather than writing the question, draw the diagram. It's much better. How much force should you impart on this car that the car picks up a velocity of 30 मतलब अगर मैं 080000 पे ये फोर्स डालूं तो 0800 10 सेकेंड्स में इसकी वेलोसिटी कितनी हो जानी चाहिए 30 मीटर पर सेकेंड. दैट मीन्स दिस इज नथिंग बट v और ये तो भाई साहब रेस्ट पे है तो इसका मतलब यहाँ पे u इसका 0 मीटर पर सेकेंड और गाड़ी का वजन कितना है 1500 kg. What a nice CBSE problem. So you should say that the force F should be equal to ma, father equal to mother. Do you know mother? Yes, I know mother. Mother is 1500 kg. Do you know acceleration? Sir, I don't know. What you don't know? V minus u by t. वाह, छा गए मेरे लाल. So this is kg into v कितना है 30 minus 0 divided by 10 meter per second square. So it becomes how much? 3. So 4500 न्यूटन. तो अगर 4500 न्यूटन आप इस बॉडी को लगा दोगे, सो बॉडी राइट नाउ इज एट रेस्ट. अगेन अप्लाई फर्स्ट लॉ. बॉडी इज एट रेस्ट. अ बॉडी एट रेस्ट रिमेन्स एट रेस्ट unless and until it is acted upon by a force to change a state of rest to uniform motion. ठीक है. अब यहां पे यूनिफॉर्म मोशन नहीं होगा क्योंकि न्यूटनियन एनवायरनमेंट में नहीं है. समझ में आ गया? चले आगे. ये प्रॉब्लम सीख लिया आपने. चलिए एक और प्रॉब्लम करते हैं. Oh, this is a very nice problem. Let's do this. So this problem is all about a truck. So we have a truck. Let us make a truck. This is our truck. Yeah, it's also like. So we have a truck. A truck starts from rest. ठीक है? ऐसा है ट्रक. बॉलीवुड मूवी का लास्ट सीन. मैं तुझे जान से खत्म कर दूंगा. A truck starts from rest. Rest means initial velocity should be equal to 0. ठीक है? And then the truck rolls down a hill. It is rolling down a hill. ये एक hill है and it rolls down with constant acceleration. Constant acceleration. That means our grade 9 problem. Rolls down a hill means this is like a slope which is a straight line. Motion in a straight line with uniform acceleration. Can we apply Suvat equations? Yes, why not? ठीक है? ऐसे सोचने का. So it travels and it travels a distance of 400 meter. मतलब यहाँ से यहाँ ट्रक आ गया and this distance is 400 meter. The truck has traveled a distance of 400 meter. Find the force 400 meter and the time taken for this is 20 seconds. So have you understood? There is a truck with a constant acceleration. It is coming. Constant acceleration means the truck should be speeding up or slowing down. Speeding up. इतना देखने का क्या है? स्लोप के नीचे आ रहा है. स्पीड अप करके ही तो आएगा. हाँ, स्पीड अप करके आ रहा है. ठीक है, बराम करके रोल करके आ रहा है और 400 मीटर का रैंप आ रहा है इन 20 सेकेंड. ठीक है. Then it's asking find the force acting on it if the mass of the truck is the mass of the truck is how much? 7 metric ton. अच्छा, metric ton क्या है? 1 ton is equal to 1000 kg. 100 kg is known as a quintal. Sir, I don't know. 1 quintal rice bag means 100 kg. 1 metric ton is equal to what? 1000 kg. हाँ, बोलते हैं ना 7 ton का गाड़ी आया है. In army there is one vehicle which will bring all the बच्चास to school. ग्लेंडल में खूब लेके जाता है. उन गाड़ियों को क्या बोलते हैं? 1 टन बोलते हैं. 1 टन मतलब 1 टन की गाड़ी है वो सब. 1000 kg. Metric means the measurement is in metric. TONNES. Like we have 7 metric ton. So we have to calculate now what is the force acting. चलो कैसे करेंगे बताओ. What is the force acting on this truck? अच्छा, where should the force be acting? Which direction the force should be acting? Tell me. Let's see. क्या ऐसे वैसे ये क्या है? What southeast? Nonsense, yaar. Which direction is the velocity? This direction. Which direction is the acceleration? So the force is acting on this direction. खत्म बात. Southeast, southwest. बोलो the force is acting behind the truck. खत्म. इसीलिए तो गाड़ी एक्सेलरेट करके आ रहा है रैंप से. I don't know. Something is wrong in either my teaching or you all don't enjoy physics or something. The vehicle is accelerating downwards. So where is the force acting? Force should be acting downwards only. That's what we have learned. F net and A net are in the same direction. Now आ जाओ CBSE बच्चा बन जाओ. चलो. Force should be equal to mother ma. Do we know M? Yes. 7,000. Do we know A? No sir. We don't know A. So how to get A? How to get A? So you use S equal to ut plus half AT square. What is S? 400. What is ut? Starts from rest. Mane laddu plus half A. What is T square? 20 square, which is 400. 400. अब कितना हो गया? Tell the value of A. A का वैल्यू कितना आया? 2 क्या? My head or your head? 2 मीटर पर सेकेंड स्क्वायर. जरा चेक कर लो, सब मीटर में है तो मीटर सेकेंड. बस ठीक है, बस चाप दो इसको यहाँ पे. 2 मीटर पर सेकेंड स्क्वायर. तो 1400 नहीं 14,000. सो वी से 14 किलो न्यूटन आ गया आपका. किलो न्यूटन 14,000. हाँ, एक एग्जांपल दिखाता हूं, जरा देख. 1 minute, I'm switching off the light. है, just see the first light and see the next 4 light. Keep your eye on them, right? All of you, you'll understand. I'm switching it on. आप ना ये 4 लाइट के में है, थोड़ा देर से क्यों जलता है? Did you see the next 4 lights? they switched on with a little bit 2 seconds delay. ऐसा क्यों है? इसके जैसा जलो ना. Why you are laughing? Example. Examples are always spot on. उस दिन भी वो एग्जाम्पल दिया कराटे वाला. He laughed, then he left the house, and when he's wearing shoe, then he's saying, "Oh, now I understood." मैं ना एक दिन I'll do your PTM in front of your dad, not mom, because I have met him once. I have analyzed him. खुंखार पीटीएम जिसको बोलते हैं ना, वो पढ़ाई लिखाई नहीं, इसका जेनेरिक बुद्धि इंप्रूव करना है. चलिए, हैव यू अंडरस्टूड हाउ टू डू दिस प्रॉब्लम? सो जस्ट सी, वी विल हैव दिस पोर्शन न्यूली एडेड टू द प्रॉब्लम्स. दीज आर ऑल कमिंग फ्रॉम द प्रीवियस प्रॉब्लम, लेकिन आपको अपना अकल लगा के करना पड़ेगा. चलिए एक और प्रॉब्लम करते हैं. लेट्स डू वन मोर प्रॉब्लम. ओके, वेरी नाइस. लेट्स डू दिस. A force of 5 Newton. ठीक है, बहुत सुंदर. आइए. So we have a mass m1. You have a mass m1 और इस पे कितना लग रहा है? There is a force say F1 which is equal to 5 Newton. A force of 5 Newton acts on a body of m1 and this body gains an acceleration of 8 meter per second square. इस body. So A1 is 8 meter. Have you understood? ठीक है, हमने कृतिक के सर को मारा कितना? 5 न्यूटन से. सर पे एक्सीलरेशन आ गया 8 मीटर पर सेकंड स्क्वायर. दिस इज कृतिक्स हेड. डू यू नो द मास ऑफ कृतिक्स हेड? नो, इट इज m1. ठीक है, एंड देन देयर इज अनदर हेड व्हिच इज पीयूषा's हेड. दिस इज गॉट अ मास ऑफ m2 एंड द सेम फोर्स. व्हाई देयर शुड बी डिफरेंशिएशन अक्रॉस जेंडर्स? नो सर, देयर इज नो डिफरेंशिएशन. सो f2 is also equal to f and f1 is also equal to f, and when we say f is 5 Newton. ठीक है, so on Piyusha's head also we have produced a 5 Newton and it produces an acceleration of 24 meter per second square. A2. ठीक है. Now in the third example what we have done, we got a thread, and we tied both the heads together. Both the heads have been tied together. That's a gift pack. We have made a gift pack with a bow, right? And we now want to find out that if you would have given the same force of F equal to 5 Newton, this combined mass AC would have gained what acceleration?
Yes.
Find the total mass.
So the force is 5 Newton, right? You have to find acceleration. So let us use the formula phi equal to massa. Yes? So A is equal to F by M. So you need A. In order to need A, you need F. You have got F. So A combined is equal to F by mass combined. So you already know A, you don't know, F you know, M combined you don't know. But what is M combined? M combined is M1 plus M2. This you know. M combined equal to M1 plus M2. But you again don't know M1 and M2. So again you apply this same thing here. M1 should be equal to F by A1 and M2 should be equal to F by A2. Now my first question, hang on. Without calculating whose mass should be more?
Uh,
Here mass,
because
obviously.
because the acceleration is higher than mass.
I don't think it like that. I think it in a very simple way. 6. 6 is a number. Here 6 is coming as what? 6 is coming as 6 into 1. And here also we are getting 6. So here it will be 1 into 6. Okay. Mass and acceleration. Say 6. If you are getting an acceleration of 6, then the mass should be how much?
6 only.
Yeah, 1.
One.
1.
My bad.
And if you want to get the acceleration as 1, then what should be the mass? 6. ज़्यादा acceleration होगा तो mass घटेगा. ज़्यादा acceleration है तो इसका mass कम होगा. नहीं, इसका ज़्यादा acceleration है. So we will find the M2 will always be less than M1. Simple. लेकिन देखो कैसा CBSE है आपके अंदर. प्रॉब्लम मिलते ही करने लग गए. अपनी जिंदगी का एक सेकंड रिवाइंड करो और सोचो क्या आज कुछ सीखने को मिला. फरहान नाइट्रेट एंड प्री रेजुलाइजेशन मिलते ही करना शुरू. चलो निकालो. हाउ मच इज द मास आउट हियर? 5 by 8. Agreed. How much is the mass out here? 5 by 24. What is the combined mass? 5 by 8 plus 5 by 24. What is the LCM? 24. 3 5 is 15 plus 5, which is equal to 20 by 24. So final acceleration should be equal to how much? 5 divided by 20 by 24. So it should be 5 into 24 by 20. 5 4 is 20. 4 6 is 24. So final acceleration is 6 meter per second square. मैं ये भी करता हूँ, मैं पेपा पिग भी देखता हूँ, मैं बाहर जाने से अड्डा भी मारता हूँ, सब करता हूँ. लाइफ को एंजॉय कर और साथ में पढ़ाई कर. पढ़ाई का मतलब ये नहीं है कि पढ़ते ही रहना है, मजा लेना है, ऐश करना है. साथ में खाना भी बनाता हूँ, झाड़ू भी लगाता हूँ, पोछा भी मारता हूँ. Enjoy life. Yes, Piyusha, it has been much long that we have not exchanged information about cartoons. I've been kept too busy with my daughter for last few days. That's why.
Have you ever watched Latest Pet
What?
It's a really good cartoon.
Which one? Pet Shop?
Latest Pet Shop.
नहीं,
Strawberry Shortcake.
बहुत दिन हो गया. मैं टीवी नहीं देखा हूँ. I'm passing through a very bad phase. I'm almost sleeping at 1 o'clock every day, getting up at 5 o'clock. My condition is severe now.
When I come home, see, my bus started coming at 4:30 now.
Hmm.
I reach at 4:30. Then school just gives like a lot of work, and then I have to study for exams. And tuition. So then I was probably 20.
No, generally after I go home, like my mom will go to sleep and all, and then the television is in my hand. जो ड्राइंग रूम वाला टेलीविजन है और बड़ा है, उसमें देखने में अच्छा लगता है. Then I do all these things. Now this cricket season is going on, so some sort of cricket goes. Otherwise, it will be either cartoon or some 90s or 80s movie where typically I'll take it to that last scene. अगर पुलिस को बताने की कोशिश की तो मैं तुम्हें खून कर दूंगा, वो सब सीन थे. Then there will be a lot of मारपीट going on. उससे देख के मजा आता है मुझे. ठीक है, राइटो. एक प्रॉब्लम और करें. हाँ चलो सब आसानी है. अच्छा, the next problem is we need to calculate about forces. The next problem is also interesting. It's something like this. देखो ये सारा प्रॉब्लम्स अगर मैं आपको लिख के क्वेश्चंस देता ना, आपको मजा नहीं आता. फिगर ड्रॉ करा करो. फिगर ड्रॉ करने से बहुत मजा आता है. सपोज हमारे पास एक मास है. वी गॉट अ मास एंड दिस मास इज 10 grams. ओके, एंड वी हैव अनदर मास व्हिच इज 20 grams. ओके, इसको छोटा कर दो. इसको हम 10 ग्राम लिख लेते हैं. एंड दिस इज इक्वल टू से 20 grams. दिस इज M2 एंड दिस इज M1. राइट. Now, which would require a greater force? Accelerating, I want to accelerate the 10 gram. I want to create an acceleration of 5 meter per second square, or a 20 gram, I want to create an acceleration of 2 meter per second square. Where do you need more force? Where do you need more force? Force is equal to what? Mass into acceleration. यहां पे कितना फोर्स लगेगा? 40. वाओ वाओ वाओ, दिस इज इन ग्राम्स.
So it has to be centimeters.
F2 is equal to 20 by 1000 into 2. Agreed? 0 and 0 cut, so it is 4 by 100, which is equal to 0.04 Newton. F2 is equal to 0.04. And if you look at F1, then is how much? 10 by 1000 into 5. That is cut, so it's 0.05 Newton. Sir, very strange. Here you need more force. देखो 0.04, 0.05. Apparently देखने से लगता है इधर फोर्स ज्यादा लगेगा. Because here the demand of acceleration is very less. सांड जैसा बॉडी है लेकिन एक्सेलरेशन नहीं चाहिए. Here body is हल्का but you need very high acceleration. This is typically the case of bullets and all. A bullet is very छोटा. My sir used to say, chemistry teacher, चाकू छोटा होता है, बड़ा बड़ा मर्डर करके दिखाता है. वैसे बुलेट छोटा होता है, ऐसे फोर्स ज्यादा है. बुलेट में मोमेंटम ज्यादा है. Anything which you think has happened with lot of impact, momentum is more. Now some bad examples. You take an SUV type of a vehicle, वो लोग करते हैं ना, और फिर जाके सीधा मेट्रो पिलर पे जाके मार देता है. SUV का मास है, वेलोसिटी मीन्स जोश में चला रहा है, minimum 180 should be the speed or 200, so your momentum is very high and you're going and hitting what? That metro pillar. It is going to make your velocity 0, means entire momentum will become 0, and it happens in how much time? Less than 3 seconds. Denominator less, numerator very high. Perfect condition to wear a garland every year on a photo. है ना? मौत ही तो होगा और क्या. द इम्पैक्ट इज वेरी हाई. दैट्स व्हाट दे सी ऑन इम्पैक्ट कोलिशन. धड़ाम से आके मारेगा बस. इन द सेम वे इफ अ फेदर गोज एंड कौवा गोज एंड स्ट्राइक्स अ मेट्रो पिलर, उसको कुछ होता है क्या? नहीं. उसका मास कम है, वो धीरे धीरे उड़ती हवा बहती हवा करके जाके लगता है, चलता है. कौवा जाता है, कौवा को कुछ नहीं होता है, आपको होता है. Therefore, small children when they run and they just get hit on some slabs or something, ये फूल जाता है ना आलूओं के, यही तो कारण है. ठीक है, तो आज का रंगारंग कार्यक्रम यही समाप्त होता है.